I did my project on Unit 2.1 tangent and velocity. I will cover what they are and how to solve for them. So a major topic is the tangent line versus the secant line. The importance of these two is they help us solve for different forms of velocity. So what is a tangent line? Well, it's a line that intersects the function at only one point, as you can see. And this is used to find the instantaneous velocity. The secant line, however, crosses the function at 2 points in the graph. And this is used to find the average velocity between those 2 points. So we'll now try to find the velocity based off a graph. This should be pretty easy as we'll be just solving for the slope. In order to do this, we'll take 2 easy points to help us solve the problem. I'm going to be using the point 1, 3. We'll be finding that the slope is the change in distance over the change in time in a given interval. So now, to find the velocity, we'll take the change in y, or distance, which is 3, and a change in x, or time, which is 1, 3 feet and 1 second. We will use it to solve for the average velocity based on the formula that the average velocity equals the change of distance over the time elapsed, as you can see in the formula. So now we will get that the 3 feet divided by the 1 second will give us the average velocity, that is 3 feet per 1 second. So our problem now asks us how to find the average velocity and instantaneous velocity. So it states that a rock's position is represented by the function f of x equals negative 2x squared plus 25x, where f of x represents distance in feet and x represents time in seconds. So we want to find the average velocity of the rock on the interval from 0 to 3 seconds. So let's try solving for the y values. So we get f of 0 equals to negative 2 times 0 squared plus 25, which will give us 25. And now we will solve for the other one. So f of 3 equals negative 2 times 3 squared plus 25, which will give us negative 18 plus 25, which is a total of 7 feet. So now we have the y values. We can use the point slope formula and solve for the average velocity. So we will take f of 0 minus f of 3 and divide that all by 0 minus 3, which will give us that 25 minus 7 divided by 0 minus 3, and we will get 18 divided by negative 3, which gives us a final velocity that is 6 meters per second. So we're now trying to solve for the instantaneous velocity, and the problem is still the same except the negative 2 is gone. The equation is now just negative x squared plus 25. So we're trying to find the instantaneous velocity of the rock and find it for when it lands. So we'll take the f of x is equal to negative x squared plus 25, and we'll find that its derivative, or the f prime of x, is equal to negative 2x. So what we just solved for is the slope of the problem, which will help us find the average velocity later. So in order to solve it, we'll rewrite the problem so that it is easy to factor out. So we'll get x squared minus 25 is equal to 0. And then we will factor it out so that x minus 5 and x plus 5 are 2 factors. And we'll set it so that x equals 5 and x equals negative 5. These are 2 factors. And so here's a very rough sketch of basically the graph of f of x, and this is just to help us solve for a real life scenario. And we know that time can't be negative, so we'll just be focusing on x equals 5, so we don't need to worry about the left side of the graph. So in order to solve for the instantaneous speed, we'll be needing to take the derivatives of and plug in the time. So f prime of 5 is equal to negative 2 times 5, and if you multiply it out, you'll just get negative 10, and you can't forget the units that are feet per second for our velocity, or instantaneous velocity, at time equals 5. Thanks for watching, and I hope you learned something from my video.